Chapter 9, Differentiation. Lesson 1, Differentiating sin x and cos x. You need to know how to differentiate sin x and cos x from first principles. In calculus, the angle will always be measured in radians, and it allows you to use the small angle approximations. Sin x is approximately x, and cos x is approximately 1 minus a half x squared. This means that the limit, as h tends to 0, of sin h over h is the same thing, is equal to the limit, as h tends to 0, of sin h can be replaced with h, because h is small, it's tending to 0, over h, and h over h is just 1. It also means that the lim, as h tends to 0, of cos h minus 1 over h is equal to the limit, as h tends to 0, of 1 minus a half h squared minus 1 over h. The ones will cancel, and we get the limit, as h tends to 0, of minus a half h squared over h, which is minus a half h, and as h tends to 0, we get 0. Now these two limits will be used inside of the first principle derivations for sin x and cos x, and you need to use them. Let's do an example. Prove from first principles that the derivative of sin x is cos x. You can assume that as h tends to 0, sin of h over h will tend to 1, and cos of h minus 1 over h will tend to 0 from before. If we let f of x equal sin x, which we're trying to derive, then the derivative of f of x is equal to the limit, as h tends to 0, of f of x plus h minus f of x over h. And this is the limit, as h tends to 0, as f of x is sin x, of sine of x plus h minus sin x over h. If we expand sine of x plus h using our trigonometry knowledge, we know this is the lim, as h tends to 0, of sine x cos h plus cos x sin h minus sin x over h. Factorizing, we can get the lim, as h tends to 0, of sin x multiplied by cos h minus 1 over h plus cos x multiplied by sin h over h. Now, as the limit of h tends to 0, of cos h minus 1 over h, that would tend to 0, and sin h over h will tend to 1. So this will be 0, so this entire thing will go, and we're left with cos x. And so therefore, the derivative of sin x is cos x. You can say generally that if y is equal to sine of kx, then dy over dx, the derivative, will be k times cos of kx. For example, if y was sine of 2x, then dy over dx would be, take the 2 out, it would be 2 cos of 2x. You can use a similar proof like first principles for cos x to find its derivative. If y is equal to cos of kx, then dy over dx will be similar. It will be k times sine of kx, but this time it will be negative. It will have a minus sign in front. So for example, if y was cos of 5x, then dy over dx wouldn't be 5 sine of 5x, it would be minus 5 of sine of 5x. And that's about it.